I'm glad you're here. Whether today was long and heavy, or you simply enjoyed drifting off while thinking about distant stars and quiet cosmic mysteries, you're in the right place. There's nothing you need to focus on now. Let your shoulders relax. Let your breathing slow, and allow your thoughts to drift gently and without effort. Tonight, we're not exploring just one star or one galaxy. Tonight, we're exploring the universe itself, vast, ancient, and still unfolding. We'll move slowly from one idea to the next. From light that has traveled for billions of years to invisible matter passing silently through space and even through you. Some of these ideas may surprise you. Others may feel distant and dreamlike. You don't need to remember them. Just let them pass, like constellations sliding across a dark sky. And if these quiet journeys help you rest, you're welcome to like or subscribe so others can find their way here too. Now, let's begin. The age of the universe. The universe is often said to be about 13.8 billion years old. This estimate comes from studying the oldest light we can see and measuring how fast space itself is expanding. But not every measurement agrees. Some ancient stars appear older than expected. Some galaxies seem too mature for such a young universe. And some scientists wonder whether the expansion of space has changed over time. Most astronomers still accept the 13.8 billion year figure. But the question remains, what if the universe is older than we think? What if what we call the beginning was only one chapter in a much longer story? Rogue planets. Not all planets orbit stars. Across the galaxy, there are rogue planets, worlds drifting alone through space, untethered to any sun. Some were born in solar systems and later flung away by gravitational chaos. Others may have formed on their own, like failed stars. They are dark, cold, and nearly invisible. Astronomers estimate there may be billions of these wandering worlds in the Milky Way, possibly more than the number of stars. Each one spins silently in endless night, warmed only by distant starlight, moving slowly through the spaces between suns. Ancient light. The oldest light we can see comes from a time when the universe was just 380,000 years old. Before then, space was thick and opaque, a glowing fog where light could not travel freely. But as the universe expanded and cooled, atoms formed, the fog cleared, and light was released. That light still surrounds us today. It's called the cosmic microwave background. Its photons have been traveling for over 13 billion years, stretched by expanding space into faint microwaves. It's a quiet glow, not from stars or galaxies, but from the universe itself, remembering its first clear moment. Strange worlds. Some planets may be made largely of diamond. In solar systems rich in carbon, extreme pressure can turn entire planetary interiors into crystalline carbon structures. At least one such planet has been identified orbiting a dead star dense, massive and likely filled with diamond lattices thousands of kilometers deep. It wouldn't sparkle like a gemstone. But beneath its surface, carbon atoms may be locked into endless crystal, quietly reflecting a universe far more diverse than we imagine. Dark matter and you. As you rest, dark matter passes silently through your body. It doesn't glow. It doesn't interact with light. But it has mass and gravity. Our galaxy is wrapped in a vast halo of it. And as Earth moves through that halo, trillions of dark matter particles pass through every square centimeter of space, every second. They leave no trace. But without them, galaxies wouldn't hold together, and cosmic structure wouldn't exist. Even now, as you lie still, the invisible universe flows through you. Neutron stars. There are stars so dense that a single raindrop of their material would weigh more than Mount Everest. These are neutron stars, collapsed stellar cores only about 20 kilometers wide, yet heavier than the Sunday. Inside them, atoms are crushed so tightly that electrons and protons merge, forming an ocean of neutrons. They spin rapidly, they bend space, and they hold matter in one of its most extreme states, balanced delicately between existence and collapse. The shape of space. The universe may not have an edge. Instead, space itself may be curved like the surface of a sphere, but in higher dimensions. If that's true, you could travel forever in a straight line and never reach a boundary, only return to where you started. Not because space loops like a tunnel, but because geometry itself bends. The universe may be endless in journey, even if not infinite in size. Drifting away. The moon is slowly leaving Earth. Every year, it drifts about 3.8 centimeters farther away, roughly the speed your fingernails grow. Billions of years ago, it loomed much closer in the sky, and days on Earth were far shorter. This gentle retreat is caused by tidal forces, a quiet exchange of energy between Earth and Moon. It's slow, relentless, and invisible on human timescales. Yet even familiar companions are never truly still. Closing tone. The universe is not silent. It hums with motion, memory, and time. Stars vibrate. Galaxies drift. Light carries stories older than Earth itself. And as you rest, you are part of it moving through space, through dark matter, through ancient radiation left behind at the dawn of everything. You don't need to understand it all. You don't need to remember any of it. Just let the universe continue its quiet work while you sleep. If so, there may be quiet, invisible threads connecting distant regions of the cosmos. Quantum echoes from the dawn of time, still present in the emptiness between galaxies. The vacuum of space has pressure. Even in a perfect vacuum, where there are no atoms, no particles, no radiation, there is still energy. Quantum physics tells us that empty space is never truly empty. Instead, it is filled with tiny, restless fluctuations. Particles and antiparticles briefly appear and vanish. Fields shift, tremble, and settle again. This constant activity creates what we call vacuum energy. On the largest scales, this quiet pressure may help explain dark energy, the mysterious force driving the universe's accelerating expansion. Unlike other forms of energy, vacuum energy does not thin out as space grows. It remains constant. And so, the more space expands, the more influence this emptiness has. It's a strange thought that the more nothing there is, the more powerful it becomes. The quiet force of empty space may be what slowly pulls the cosmos apart. Black holes and the long fade. Black holes are famously dark, so dense that nothing, not even light, can escape their gravity. But they are not completely silent. According to physicist Stephen Hawking, black holes emit a faint glow called Hawking radiation. Near the edge of the event horizon, quantum effects allow tiny particle pairs to form. Sometimes, one particle escapes, while the other falls inward. The escaping particle becomes real, and the black hole loses an almost immeasurable amount of energy. Over unimaginably long spans of time, this slow leakage causes the black hole to shrink. For a black hole, the mass of the sun, this process would take far longer than the current age of the universe. Trillions upon trillions of years. Not an explosion, not a collapse, just a slow, quiet fading into darkness.